G'day everyone and welcome to this Share Cafe due diligence webinar this time around. Now we run these events in conjunction with our research business, which is Corporate Connect. So there's a team of analysts behind what we do who continue to look for insights on an ongoing basis across the market. Now we plan to offer these due diligence webinars into 2022, and that will include companies outside of who we research. Now, the purpose of this due diligence webinar is to take a deep dive and an examination into the company presenting and to be objective, not promotional. We want to give investors institutional quality-like insights in a digital format. Now, our analysts discovered Novonix at the beginning of the year and the stock was around $2, and we reached out to work with them, with both the company and ourselves recognising that there was an absence of quality research on the company and also the EV sector in the US in particular. Now, since then, Novonix has had produced a staggering 734% return for 12 months and grown into a $4.5 billion market cap, and has recently been included in the ASX 200 index. Now, that's an incredible achievement for 12 months. Now, today's webinar will be broken up into 4 segments. The first segment will talk about the company structure and how Novonix operates. We'll then look at an update on recent events. We'll then look at the US in particular, the US market, and then we'll finish on a discussion around the cathode and the full technology suite that Novonix uses. Now, we'll stop at each segment to ask some questions, so don't forget to ask questions in the box provided. Today, we welcome the CEO, Dr. Chris Burns, who will present. Chris, over to you. Thank you. You might want to turn on your camera, and thank you. It's coming through right now. Chris, over to you.
Great. Thanks, Tim, and happy to be here and get the opportunity to present the company and also give some feedback and hear some questions around, as Tim said, all the things we've been doing for the past 12 months and also where we're going. So why don't we dive in? We'll go to the next slide. Our standard notice and disclaimers. Tim outlined where we're going to go, and we'll stop and spend some time in each of these sections. Let's start with the background of the company, what we're focused on, and then spend some time on the past 12 months of progress we've made, focus on the US side and a lot on our anode materials business, which of course is front and center within our immediate term strategy, and then really look at how that plays into our technology profile for our longer life battery technologies and new technologies that we're working on, such as the cathode materials. So next slide. So Novonix is a battery materials and technology development company. We focus on better performance batteries, and for us, that means longer life and lower cost. When you think about the market moving to electric vehicles and energy storage systems, we're starting to move to a demand profile on these batteries that prioritizes cycle life and cost. We've come so far in the past decade in terms of improving charge time, improving energy density, and decreasing cost and improving lifetime. But when you look at the impediment still of further adoption in electric vehicles, the biggest issue is the batteries cost too much. And coupled to that is the concern about how long the batteries will last in the application. So Novonix really focused on how we can drive down the cost of batteries through process technology and improve the lifetime. Because the other important thing to recognize is that when we move away from consumer electronic devices with required lifetimes of several years to vehicles and energy storage systems where the required lifetime is 10 plus years, the best way to reduce the cost of a battery is to think about the total cost of ownership of that battery. And instead of focusing only on dollars per kilowatt hour of upfront cost in the cell or the pack, if you can increase the longevity of the battery and the application will use that, that's the best way to decrease the cost. And so that's really where we've been focused. My background personally, I'm over 12 years in the battery materials and technology space. I did my PhD with Dr. Jeff Dawn, who's a leading researcher in the world of materials for lithium-ion cells. He's worked exclusively with Tesla for the past 5 years, and recently he's joined us as our chief scientific advisor. And I started our battery technology solutions division back in 2013. At that point, we were focused on trying to solve for the question of how were we going to know how long batteries are going to last, in shorter, reliable experiments. Because it was very easy, 10 years ago to think about consumer electronic devices and need a 2 or 3 year lifetime and test the battery for 6 months and feel confident. But when you started saying you need a 10 or 20 year lifetime, we needed to focus on a technology that was going to give us answers to battery performance in weeks instead of many months. And so our battery technology solutions business developed that technology, and it really sits at the core of our business, incubating new intellectual property and working across the sector with participants across the value chain, as well as serving as our research and development center. We'll spend a little bit of time talking about that. I also spent 2 years from 2015 to 2017 leading a team for Tesla. I was their first technical employee in Canada focused on cell testing and battery materials. And we worked a lot with our supply chain group on evaluating potential material suppliers coming into this decade of the 2020s. And that turned a lot of our attention to graphite, and specifically synthetic graphite, where I saw that there was going to be a shortage of companies with the right technology and the scale to supply this industry that was going to grow exponentially in the United States. And so in 2017, we were working on technology in that space with Novonix, and we started our our anode materials division with a focus on long life synthetic graphite. And we'll spend some time later speaking about why that's so important. And while we're going to spend the most time talking about that, it's important to recognize that Novonix is not a graphite company. We are a diversified materials and technology company. And over the past year or 18 months, we've made announcements about intellectual property that we filed in the cathode synthesis space for high nickel cathodes. And we'll spend a few minutes at the end speaking about that. A partnership with Amera Technologies, a subsidiary of an energy utility company, to focus on designing and manufacturing battery packs for microgrid systems. And we continue to incubate new opportunities within our BTS division that we look to grow into standalone divisions of our company that are scalable, such as our anode materials division. So we'll go to the next slide. So our leadership team, I've given my background. Our CFO, Nick Liveris, Ross DeBatar, our SVP and General Counsel, and Suzanne Yates, our Financial Controller and Secretary. On the technical leadership side, we really view, because of our commitment to investment in research and development for new opportunities, we look at Dr. Jeff Don, who I spoke about, and Dr. Mark Obervac, who's a researcher at Dalhousie University, whose group we sponsor, and where the cathode technology spawned, and we own all of the intellectual property rights to, as key parts of our technology leadership team. And our board of directors has a breadth of experience. Our chairman, Admiral Robert Natter, most notably Andrew Liveris on our board, former CEO of Dow Chemical, Tony Vellis, who's just stepped down from our chairman to our deputy chair, John Agladria, who's our representative from Phillips 66, and we'll speak about their investment in the company later, Trevor St. Baker from the energy sector in Australia, and Robert Cooper, who's been with the company for a number of years. Next slide, please. So I want to dive a little deeper on our battery technology solutions business, because it's an incredibly unique advantage that Novonix has across the industry. And so our battery technology solutions business, as I said, was founded on technology to innovate and do research and development faster. And that team, we have a full battery pilot line installed where we can build cylindrical format, pouch format cells, thousands of test circuits, where we're testing batteries that we build with new materials or batteries from different major suppliers, all with the name of qualifying different materials or learning about performance of different cells for different applications. And we do that work with third parties, as well as, of course, with all of our internal projects. And the advantage of doing that work with third parties is we work with people all the way from the battery material refining sector through to specialty battery materials, anode, cathode, electrolyte. All the major cell manufacturers and many of the auto OEMs are customers of this division. And so we go all the way to that EV and ESS OEM side. And this gives us huge visibility in not only what upcoming technologies and materials offer, but also where EV and ESS companies see the requirements down the road. And that allows us to look at that landscape and decide where we want to invest in new research and development, or focus our efforts where we see opportunities to fill gaps or build build scalable divisions within the company. And as we look at our mission of longer life, lower cost batteries, the specialty battery materials, anode, cathode, electrolyte, really jump to the front as the most important sector for us. And of course, that's our anode materials division, our cathode materials group. And this is because those materials represent the bulk of the cost of a lithium-ion cell. And as well, they define the chemistry, and therefore they define the longevity. So improvements we can make in the process technology there are going to help us drive costs down and improve cycle life. And then our partnership with Emera is a step downstream toward the pack manufacturing side. But that ability to work with companies across the sector really allows us to know where the state of the art is as it continues to evolve so quickly, and continue to benchmark ourselves to companies of relevance as we present our materials to the cell manufacturers and auto OEMs. Next slide. And so when we think about how we kind of use that division, it really is our internal R&D center where we do all of our testing, designing, prototyping of cells, and proving out the performance of the different materials and technologies that we work on. And so then our divisions, stay focused on their core technologies. So our anode materials group is focused on making different graphite materials with different performance and starting to scale that process up. And of course, we'll spend more time speaking about that. But the ability to make those materials in-house, to provide them to our R&D center, build them into full-scale batteries, and get results about their cycle life performance in only a few weeks. With other companies, that process of making materials, getting them built into cells of the third party, and doing cycle life testing could be many, many months. So the ability to shorten that research and development cycle really gives us this advantage to innovate faster and reach the product specifications that these customers are looking for. And of course, that capability and the materials that we're working on is what drew the interest of Samsung SDI, who signed an original agreement to purchase 500 tons of our graphite material, and Sanyo, which is the cell building arm of Panasonic, with an MOU to evaluate our mass production materials after positively qualifying our pilot line materials. So this has really positioned us to be the first supplier of battery grade synthetic graphite to a major OEM in North America. And now that model that we're running with our anode materials division and the feedback loop with our BTS division is exactly what we're implementing now with our cathode materials team, our partnership with Emera, and a number of other technologies that we're coming up at earlier stage, from inside our team or from our work with the university. So I think we'll pause here and talk a little bit more about the company and how we operate.
Thanks, Chris. There's a couple of questions here. One, you've just mentioned the Emera partnership. Can you give us a bit more detail on that, please?
Sure. So Emera is a Nova Scotia-based energy utility company. They own a number of power companies across Canada and the United States, including the local power company in Nova Scotia, where our Battery Technology Solutions division is based. And they have set up a subsidiary, Emera Technologies, and Block Storage Energy, which you can find online, that's focused on direct current microgrids. And so the goal of the systems is, as they look at new residential builds in primarily the Sun Belt in the United States, so the southern half of the United States, we need to look at the way we transform the way we utilize the grid. And instead of thinking about houses as a consumption point of power, they should be a generation, storage, and consumption of power. And so this is really moving toward new builds that will be pockets of communities which are essentially off grid. I mean, the grid will be the backup, but the primary source of power will come from homes, and solar will be stored in vehicles and on-site battery storage at the home and community level, and then tied back to the grid for stability. So as part of that, they evaluated the types of batteries that exist in the market for more traditional energy storage applications, peak shaving or longer duration storage or UPS style storage. And the challenge is that in a microgrid, the use on the battery is constant. It is not store the energy, let it sit there and wait until you need it. You are always pushing and pulling power as you generate and as you consume at different levels, not only within the single home, but within the community. So they found that existing systems built by most of the major suppliers really didn't meet the criteria that they needed for the performance of their cells, of their packs. And so they partnered with us to evaluate different suppliers of cells and design pack systems and battery management systems that would suit the unique needs of a direct current microgrid. And so we've been working on that project now for a little over a year, and we've made great progress, and we're starting to work toward building prototypes that will be used in some of their demonstration sites to prove out the utility of their microgrid as they look to partner with residential home construction companies and utilities across North America.
Thanks, Chris. We've got lots of questions coming through. We've got time for a couple more in this
I'll answer shorter.
Yeah, no, that's fine. There's questions around Sanyo and their timing. So the question is requalification kind of the main catalyst required to convert Sanyo's MOU to a binding sales agreement?
Yeah, there's a few steps as you look at the process with Sanyo or anyone really. And so, you go through pilot scale sampling of materials that they'll qualify at the kilogram level, and then you move up to them qualifying materials at the tonnage level that they'll do in their full scale pilot line and build thousands of cells and likely share those cells with their automotive or ESS partners. And that's when they can validate and go through their full supplier audit process, when you really have the plant stood and operating. And so as people know, that's the process that we've really been focused on through the course of this year, and really more recently been operating our second generation systems reliably, repeatably, generating material that we can give large volume samples to Samsung, Sanyo, and others. And of course are also working on the installation of our third generation system. So that process, each of those windows is, let's say, a 6 to 9 month window. And so we've given mass production samples to a number of people, including Sanyo, and they're going through, they will be going through that reevaluation.
And Chris, there were comments from Elon Musk highlighting a shortfall in the US graphite supply chain. Might have spooked the share price in the market temporarily. Can you give us your insights on his comments?
They're simple. He's absolutely correct. We're going to talk about the market demand in the U.S. and our goals for scale, right? But I mean, he said two important things, right? He said that Tesla was commenting that there is a shortage of, there will not be suppliers who can reach the specification and volume requirements of Tesla. And that comment will be true this entire decade because of the volume side. I mean, the demand side for graphite in the United States will outpace the supply side significantly. And it's a challenge, and it's where the United States is really waking up to this issue of whether they will be forever reliant on the offshore supply chain and only subsidizing their needs domestically, or whether they can invest in bringing more capacity online for key materials. And that's where we see the infrastructure law coming in and funding for this type of work. But the challenge I see specifically for synthetic graphite is that over the past number of years, I think people have been waiting to hear that some new technology was going to be ready to displace graphite. And I think it's become more and more obvious that that's just never going to happen. New technologies will come in and participate in the market, but there will never be this displacement of graphite. And because of that, we've had a lack of companies focusing on developing the right technologies. And that's going to further amplify this gap in demand and production supply in the US.
Right, thanks, Chris. I'll let you continue the presentation.
Okay, great. Let's jump to the next slide. So this is a summary really of the past 12 months or so of some of our most notable progress. And some of them I've hit a little bit, but in December of last year, we announced our partnership with Harper International. So a big focus of our synthetic graphite process technology is in the graphitization step. So we need to heat materials to very high temperatures, around 3000 degrees C. And Harper is a US-based, long history of building high temperature furnace systems. And we announced this partnership where they will be the manufacturer of our proprietary furnace systems of the Gen 2s that are running now at our facility in Chattanooga, and the Gen 3s of which we're installing the first ones now. In January, we announced Jeff Dawn joining our group as our chief scientific advisor when he came online, and he came on in July. It's great to have somebody of his caliber and expertise working with us on our technology programs. In January, we were also selected by the Department of Energy to receive an up to $5.5 million US grant with a focus on developing our process technology further. And we'll speak about that in a minute. In February, we extended or signed a new 5-year agreement with Mark Oberbach's group. And I mentioned that he's a researcher at Dalhousie with a team of graduate students and research associates, where we support, with support from the federal government of Canada, the financial needs of the group in exchange for first right to all of the intellectual property. And the cathode technology, which we'll speak about at the end, started from that group. We also announced the partnership with Amera, which we spoke about. And at the end of February, we raised about 130 million Australian dollars to focus on funding our 10,000 ton scale up in Chattanooga. And we'll speak about that. We installed our first second generation furnace system, and filed our first registration statement with the NASDAQ to look at establishing a listing here in North America. In June and then in July, we went under contract and closed on our new facility in Chattanooga, Tennessee, over 400,000 square feet manufacturing space, a pristine facility, perfectly suited for what we're working to do, and we'll touch on that a little bit later as well. And then, of course, say the most notable event of the year was the announcement of Phillips 66 investing $150 million into the business. Phillips 66 is a global supplier of petroleum needle coke, one of the primary input materials. And so the partnership with them will give us supply options in the United States, technology collaboration, and it's a huge validator for, not just the growth where we want to go, but our position in the market, as Phillips looked at many companies across this space that they could work with and chose Novonix to make this sizable investment with. And I mentioned earlier on, Jana has recently joined our board, and we're excited to have her as a representative of Phillips 66, who's now our largest shareholder. And then not on here, but Tim mentioned we were recently indexed into the ASX 200. Next slide, please. So I want to touch more on Phillips 66. As I mentioned, they are a diversified energy manufacturing logistics company. I mean, they are a household name in North America. Some stats on the size of the business, but most importantly, as it relates to us, they are one of the world's largest suppliers of petroleum needle coke, which is the best input material to make high performance, long life synthetic graphite for lithium ion cells. And they have production of these materials in Lake Charles, Louisiana, and in Humber in the UK, and they service a significant amount of the existing anode market. And so their investment will go toward our further expansion in our production goals toward our 40,000 ton 2025 target. But again, this partnership is much more than financial, because it is a supply technology collaboration partnership where we will be working with them to build a robust supply chain, fully looking at the lens of US sourced materials produced, starting with needle coke from Phillips, processed in our facilities and delivered domestically in the United States. Next slide, please. And the other thing in our recent events that I said we'd touch further on is our Department of Energy award. This was something that we applied for, in the middle of last year, roughly. It was a partnership with Phillips 66. So of course, our relationship with them, goes back significantly further than the recent investment. And Harper, our partner on the furnace manufacturing. And the goal of that system was to build our 3rd generation systems, the first of which is being installed currently in our new Riverside facility in Chattanooga, which we look to be the most efficient graphitization technology to use to produce these high performance lithium ion battery graphites. And so this is all part of what will be our technology advantage in the United States and with our process technology. But again, we're going to be talking about it, in a bit. We need to reach scale, and the market needs more scale because the demand is essentially going to be insatiable. So I think we'll stop and probably dive a little further on some of those events.
Yeah, thanks, Chris. There's some questions on the timing of the NASDAQ listing. You mentioned that as a milestone for moving forward.
Yeah, we haven't given any specific details on the timing, and nor could we, but we have we have registration statements in with NASDAQ under review, and we're looking forward to hopefully bringing that listing online sooner rather than later.
And recently, Phillips 66 announced, it's a question here, their intention to participate in EU anode market through their site in the UK. Is there a role in for Novonix in this move?
So there's certainly an opportunity there. I think that Europe faces the same challenge that the United States does, and we'll speak about that kind of supply-demand imbalance, and some of the lack of technology partners that exist in Europe in the synthetic graphite space. So certainly we have active dialogues with Phillips about, as our first priority is the United States, we look at how we can work with materials coming out of Humber and partners in Europe to move our technology there as well. As Europe has always been part of our roadmap plan, they're in many ways more aggressive than the United States, and we're really talking about customer profiles that become very similar and input materials that we can work with Phillips to cater. And so as we reach scale and start having material in significant volume in the market in North America, it will be a natural progression to do the same in Europe.
And just quickly, and we'll finish on this. Can you give us, you've got a government grant there, can you give us an update on the political developments in the US, particularly with the signing of the $1.2 trillion infrastructure bill? Do you continue to see yourselves kind of well-placed to access low-cost funds?
Yeah, absolutely. So I think that for me, it's very exciting to finally see this type of commitment from the government in the United States. I think there's always been a huge amount of financial support in the research and development side of the Department of Energy, and that's always really focused on these next generation 10-year-out technologies. And as I said, I think part of that is what's led to this gap in today's technology not being existent at all at scale in North America. And so, out of that infrastructure law funding, 3 billion of it, 6 billion is for, battery processing materials, and about 3 billion of it is really directly for scale up of manufacturing of these materials and recycling, I believe. So there's a significant amount of capital that they're going to start looking at how to distribute in about May of next year, based on when the infrastructure law was signed. And they will be looking for partners that have qualified technology, a path to market, downstream customers. Our relationships with folks like Samsung and Sanya are, of course, very important, and other partners surrounding their ecosystem. And again, where the support of a company like Phillips 66, will play a role in positioning us as certainly a leading candidate, we hope, for that type of funding support. And so they have programs in the loan program office for, debt for these types of expansions. And now the infrastructure law also gives grant-based opportunities for the very same type of support.
Great, Chris, I'll let you continue. Thanks.
Okay, great. Let's go to the next slide. So I want to spend a few minutes kind of talking about the, material market share and why we really think graphite is so critical to, not just the next few years of the battery technology landscape, but the next few decades of the battery technology landscape. And then, really where our Novonix Nanomaterials division is positioned. And so this is data from Benchmark looking at cathode and anode market share mix, in 2020 and onwards to 2030. And so, they're very bullish that NCM will be the dominant cathode. And I think, likely we will see more lithium iron phosphate participation as we see cell manufacturers driving that cost down so significantly, and automakers adopting that for the lower range vehicles. But most importantly, on the anode side, they see the market share of graphite maintaining 90% by 2030. And when you start thinking about the scale of batteries by 2030, there's going to be 4.5 to 5 terawatt hours of battery production by 2030. So even that 10% wedge of alternative anodes, such as silicon, lithium metal, lithium titanate, and others, they are forecasting a market for that that's basically the size of the entire battery market today. right? And so it is not saying that there's not a home for these new technologies, but that the main dominant technology will remain graphite. And that's simply because it is the longest life. It's the only anode material that has been proven to be able to last thousands of cycles as we move to a trend where demand for the applications is requiring that type of cycle life. So on the next slide, one of the things that we really look at is driving that, and we've been following for a while, is vehicle to grid. I think that there's so much focus on electrification of vehicles right now. And I think you're going to really see in the next few years a huge amount of that focus not shift to, but you're going to see much more focus on energy storage, because cleaning the transportation sector through electrification is critical. But the best way to reduce our carbon impact is to continue to move toward a more sustainable grid structure with renewable energy, renewable power generation. And as you do that, it inherently increases the demand on the amount of storage you have within the grid. So energy storage is going to grow, I think, significantly more than many analysts have it forecasted. But a key part to that to consider is that it's kind of crazy to think about a world where vehicles are not playing a role in distributed storage of energy for the grid. As it stands right now, I have a Tesla in my driveway with a 100 kilowatt hour battery pack in it, but I could go spend $10,000 and put a 12 kilowatt hour, or whatever the current power walls are, battery in my house for backup. Well, why would I do that if I could access the 100 kilowatt hour battery in my vehicle? And we've seen Volkswagen announce that all of their MEB based vehicles will be vehicle to grid compatible. The Model 3, the Model Y infrastructure or architecture is bidirectional. Nissan committed to this with the Leaf. The new F-150 Lightning is committed to this. So this is a trend where all of a sudden, you can't think about the requirements for vehicles to be, a car is going to be driven 200,000 miles, and that's how many cycles it needs to last. This is a trend that's going to increase the cycle count demand on vehicles significantly if they are used regularly as energy storage assets for the grid. And the other is that as you look at the adoption of more and more autonomous driving, you will see the driving profiles or the number of miles being put on vehicles increasing. And so both of those are reasons why today the target, let's say, might be 1,000 cycles as the minimum for getting to electric vehicle ready. But we believe over the next few years, that 1,000 cycles is going to creep up for most cell chemistries and most vehicle applications, which is going to drive people back further into realizing that synthetic graphite is the best anode to meet those types of cycle lives. So on the next slide, we'll look at, currently that synthetic graphite supply chain. And this is going to start to feed into the focus in North America, right? And so if you take as an example, material from Humber, Phillips' site in Humber, being shipped to China for processing, graphitization in Inner Mongolia, where there's lax regulations, and then eventually being transported back to southern China for finishing and over to the United States to a factory, that you're talking about material that could move almost 25,000 miles between origin and final use. And now if we look at our opportunity with Phillips 66 in the US, we can take material from Lake Charles, bring it to Chattanooga, process it, and then there's a huge number of plants within a few 100-mile radius of Chattanooga. LG, SK, Volkswagen will build all their vehicles there. There's a growing sector in that Southeast corridor where we can shorten that entire supply chain distance to well under 1,000 miles. And this is starting to become important as we look at why there are opportunities now to grow this technology in North America. We'll talk about the demand side in a second, but some of the key factors in the cost of making these materials are the energy, where the United States has access to some of the best low-cost sources of clean energy. These logistics they cost money, as well as they are carbon intensive. And so as our customers, cell suppliers, and OEMs focus more and more on carbon intensity, these are things that give us in the United States a competitive edge over what's happening in the existing supply chain today, let alone improvements that we can make on the process technology, and then the need for independence from foreign sources and the demand that's finally going to exist in the United States. So on the next slide, is really looking at how much that demand is becoming apparent. You know, at the beginning of this year, there's about 200 gigawatt hours of capacity announced or installed. And, you know, I remember watching Tesla make the investments into the first factory in Nevada and LG into Michigan. And this was so exciting to see the cell manufacturing coming to North America, but they were simply buying all the materials from the existing supply chain in Asia. And that's one of the reasons in 2017, we really got focused on building supply chain here, because it was apparent that all of this, the manufacturing was going to grow here, and it was eventually going to necessitate a local supply chain. And it really took this year for that to take off. And now in this year alone, we've seen over 350 gigawatt hours of announced capacity to come online in the United States. All of this with a supply chain of materials in the US that's essentially non-existent. So if we look at the next slide, it's going to outline what that really means for some of these key materials, right? In an assumption of using NCM graphite cells to supply all that capacity, by 2025, the North American supply chain is going to need over 600,000 tons of graphite and almost 1 million tons of the cathode metals, nickel, manganese, and cobalt, and then growing by 2030. And I think those numbers will continue to grow as more factories get announced. And like I said, the existing supply chain for these materials, processed anode and cathode, is essentially zero. And so if we look at the next slide, it's really where we want to take our anode materials division. I mentioned the funding that we raised earlier this year, taking us to our 10,000 ton level by 2023. And then we want to go to 40,000 tons by 2025 and onward to 150 or more thousand tons by 2030, you know, really scaling with customer demand at that point. But if you look at our 2025 year of reaching 40,000 tons, that's a year where all of those most of those factories have all come online. And the demand for this type of material domestically is over 600,000 tons of material. So while 40,000 tons will be an amazing accomplishment for the business, it's a drop in the bucket of the necessary domestic supply chain, let alone global supply chain. So while we have great technology advantages, and we'll speak about those, the industry needs suppliers to reach scale, you know, almost desperately, to solve for that, you know, challenge that Tesla stated, that there are not suppliers that can meet the volume demands of people, of Tesla specifically now, nor of the rest of the US market. So on the next slide, shows a bit about that technology improvement and performance. And so these are cells built, the ones labeled natural, synthetic, and Novonix are identical cells built on our pilot line at BTS with a commercial, commonly used natural graphite, a long life synthetic graphite from China, and then one of our synthetic graphite materials that we produce in Novonix. And the top chart shows this Coulombic efficiency metric, where in only 10 or 20 cycles, we can measure the efficiency of these batteries, which translates to how long they will last, and weed out better performing cells quickly. And the cell labeled Tesla is an old Model S cell before there was silicon in the anode, really just as a point of reference to show that the cells that we make are competitive with the best cells in the world. And as you can see, we can significantly outperform other synthetic graphites, which outperform natural graphites. And when you go to kind of the traditional 1,000 cycle life test, you can see that natural graphite will maybe reach 80% at 1,000 cycles, right around that. And if you go look at many early stage natural graphite companies, they put data out there that really just shows that, and it's very consistent. And then you have synthetic graphites, which are over 90% retention at 1,000 cycles. And then when you move to our synthetic graphite, 95% retention at 1,000 cycles almost. And so this really gives you this opportunity where if you have applications that need thousands of cycles, we are providing some of the best materials for that class. And when you think about an application that actually requires that, offering a cost reduction up front of 5% in the cost of the battery is insignificant if we're offering an extension in the battery lifetime of 50% or 100%, because the total cost of ownership drops so significantly. So we focus so much on thinking about dollars per kilowatt hour per cycle over the life of the battery, instead of only the upfront cost of dollars per kilowatt hour. And we're seeing more and more acceptance of that approach as it's apparent that the cycle life demands on these materials are getting higher and higher. So the next slide shows the new facility that we purchased in Chattanooga. So over 400,000 square feet. This will house our up to 10,000 tons of production that we'll bring online by 2023. We recently held a ceremonial opening of the facility just a couple of weeks ago, and we're very lucky to have the Secretary of Energy, Jennifer Granholm, attend the event, speak about the significance of bringing supply chain here and manufacturing jobs in the country in this transition to electrification. And really shows the government's support now of seeing companies in this space, in the supply chain, which there are very few, and the importance that they're going to have to play to support this electrification for the country.
Thanks, Chris. Some questions here. Now, Ford and SK Innovations have got a gigafactory, or announcing they're building a gigafactory in Tennessee, and General Motors and LG Solutions have done the same. What are the factors kind of influencing the build out of the kind of EV ecosystem in Tennessee? And how important do you think this thematic is for the state? And what benefits does it provide having everything kind of in that EV ecosystem?
Yeah, I think the Southeast corridor and, Tennessee in particular have done a phenomenal job attracting this sector. And, you can see some of the other names that spoke, the House of Representative Chuck Fleischman, the Economic Development Agency, their Commissioner Bobby Rolfe, and some of the mayors and former Senator Corker are all Tennessee focused. And they really spoke about, how important it was for Tennessee to focus on bringing this work to the state. And they've done a great job through doing that, through the incentives that they offer, frankly. And as well, the Tennessee Valley Authority, as I spoke about, is one of the best power utilities in the country to support clean sources of low-cost power. And whether we're making the materials or you're building the cells, energy inputs is a significant cost and carbon impact. And then I think as you look at that, geographically, that Southeast corridor, it has great logistics and great access to the entire eastern seaboard, and therefore most of the population of the country, right? So there's a lot of great reasons to be there, a strong labor force. We're tapping into all of that. We started the company there, and when we went through the site selection process and ended up buying this Riverside site, it became more and more apparent that Chattanooga was going to be, one of the best competitive places in the country to do this work.
And the vehicle to grid is fascinating, and that seems to be a focus for both VW and Ford, who are two major participants in kind of the ecosystem in Tennessee. Now, your cell chemistry exhibits long life. You seem well positioned rather to benefit from this. Is this correct?
Yeah, exactly. It's one of the many reasons that we really focused on ensuring that cycle life was one of the most important criteria for us in producing, technologies for this sector, and what drove us to synthetic graphite, over natural graphite because of the improvement in cycle performance. And whether it's because of vehicle to grid or autonomous driving or the adoption of ESS needing thousands of cycles, there's many trends that are going to push you towards cycle life and cost being so important. And I think, evidenced by this is that over the past decade, there's been such a focus on energy density, right? Tesla built 400-mile vehicles almost just to prove to people that they could exist, because 10 years ago, people said, well, the problem with electric vehicles is they can't drive far enough. So they had to kind of prove that wrong. Then they said, okay, well, now they can drive far enough, but there's no infrastructure. Well, I mean, it's really incredible to see the investment they've been making in the supercharger network and how far back that dates, to now say, no, you don't have to worry about range. And now they've been improving charge time, so you can get in and out of superchargers faster. And so we've been solving a lot of these problems, and now suddenly we're in a space where people are saying, yes, we're going to use lithium iron phosphate chemistry, a low energy density cathode, because it's cheaper and it can last longer. And we're going to put that in our, most common vehicle formats, our lower cost models, and we're going to use, the expensive or even the specialty materials into our high class, low volume models. And it makes perfect sense as you really think about what the difference in requirements for those different vehicles are going to be.
And finally, just a quick one. Given your facility here, and there's lots of questions, markets always like to look forward. Can you talk to kind of expansion of your production targets moving forward?
Sure. So this will suit us through our 2023 10,000 ton level. And we've been working on our greenfield engineering for building a new site that will take us through our 40,000 ton and beyond levels, right? And so we have been working on that project for some time and are really starting to engage in the early site selection process now of where we will house that. And, of course, are looking in Tennessee, but other jurisdictions as well, because it will take time to bring those facilities online, greenfield build of a large facility. And as you saw, the demand curve will wait for no one, right? And so we're continuing to invest in expansion. This is the model we've taken from as early as this year, the beginning of the year, raising a significant amount of capital to make this happen so that we can meet these production targets of relevant numbers, at times that factories were going to be needing them.
Thanks, Chris. I'll let you continue.
Sure. So we'll wrap up the next couple slides. And, as advertised, I said we talk a lot about the graphite division. It's front and center. We're investing a significant amount of capital there, the partnership with Phillips 66. But it is not the only technology that the company is working on. And I think most recently we made announcements about, and we've provided small updates on the progress of our cathode technology. And so back to the vein of making long life, low cost battery materials through simpler process technology that can be cheaper and scalable in the US. We developed and have filed patent applications around the technology to, without the use of chemical or wet chemicals at all, synthesize high nickel cathode materials, and a focus on single crystal materials because, again, they provide longer cycling performance. And as we start to benchmark some of the materials that we've been making through our kilogram synthesis line, we're seeing that we can hit the same first cycle efficiency, capacity targets, and early cycling performance in coin cells as leading commercial single crystal cathode materials. And so over the coming months, we're going to be scaling these materials up, building them into full cells on our pilot line and doing exhaustive performance testing. And we've invested in, and some funding support was announced just yesterday for our pilot line, our tonnage scale pilot line, which will be a 10 ton per year nameplate line at our BTS facility in Canada, to prove out this technology at that commercial scale. Because the cathode market, as we look back on previous slides, has a value that's significantly higher than the anode market because you need more kilograms of cathode per kilogram of anode, and the cost of cathode is significantly higher than the cost of anode. And so technology in this space, this is a couple of years behind our anode technology and commercialization, but we're looking to invest in it and move it quickly because it's showing very promising results. And so on the next slide, as we think about technology moving forward, this really shows the type of improvement you can get with working with the right materials. And it's converted here to equivalent driving miles, really around this concept of this 1,000,000-mile battery performance with the assumptions on the right. And when you use a traditional, in blue, NCM 622 polycrystalline with a synthetic graphite, you can achieve a couple 100,000 equivalent miles. When you change for single crystal NCM, you can go over 500,000 miles in these formats, in these experiments. And when you improve the electrolyte system with systems like those that we filed provisional patents around, you could hit that 1,000,000-mile number. And then you start seeing the significant gain when you change out that synthetic graphite for our Novonix synthetic graphite. And we saw similar data on the previous slides. And now our goal is to be able to go to this next scale of synthesis with our single crystal NCM materials and be able to show a new curve, which will show all Novonix technology, cathode, anode, electrolyte, with at least in line with this current green line or better. And that's really showing that across the sector, Novonix is working on technologies that are best in class, not just in anode, but other divisions. And those are where we have opportunities to continue to invest and bring those to market over the coming years and build a group of divisions within our company, each scaling and focusing on key technologies in the industry. So I think the last slide is coming up, and we'll wrap up. I think I'm a little over time, but our battery technology solutions division really gives us leading insight into the entire landscape of technology. And we use that to maintain a leadership position in EV and energy storage technologies. We're focused on scaling our anode materials business, as we spoke a lot about, and proving out our cathode materials technology at our pilot scale, which will be happening over the next calendar year, and continuing to invest through internally and with our partnership with the university in new intellectual property, which we think will be able to build new divisions, with strong growth and profitability outlooks for over time. And that's really the future of Novonix, is a diversified set of divisions focused on their core technologies to support the supply chain, which has so much work to grow, outside of Asia. So thank you.
Thanks, Chris. We've still got a big audience on time, so we'll continue. Don't worry about the time.
All right.
Can you question here? Can you update on us whether Samsung or Sanyo are testing and evaluating Gen 2 anode material, or will they need Gen 3 anode material to lock in a contract?
So we've been working with them around our Gen 2 materials now, as we'll be, producing our Gen 3, or bringing our Gen 3 furnaces online shortly. And so there'll be supply options from those furnaces. But as we look at the future scale of Novonix, it's our goal to be able to transition to our third generation systems, which have, simply put, better scalability than our second generation systems. And so because of the timing of these two, bringing online our second gen and having those materials in people's hands, we would look at a requalification through the third generation system as likely shorter if we had to go through that, because the entire process is the same. We're essentially doing one step through a different machine. And so the proof points on the performance will come out quicker compared to the difference of moving from pilot scale to mass production scale.
And Chris, you've had the businesses, Novonix has had significant tailwinds with government support and funding moving forward, a wave of kind of clean energy investors. Where do you see your risk, and kind of what worries you?
Well, I think, for the longest time, what worried us was the win question. So, we were very bullish on, the adoption of vehicles and energy storage systems. And, since we really set up our group this way in 2017, really felt it was only a few years out. And now we're sitting here in 2021, and it's pretty evident that, 2023, 2024, those are the takeoff years for these demand curves. And so for us, the biggest focus is continuing to execute on scale up, because, as I said, technology advantages aside, the most important thing for us right now is to be delivering at volume, because a few years ago, when we signed the agreement with Samsung, they were willing to take a volume of 500 tons. Then we started hearing from people that 2,000 tons was a minimum contract volume. Then we started hearing from people that 10,000 tons is a minimum contract volume, right? And so there's a cascading effect, which, because we are growing into it, is a good thing. But if you're late to that, suddenly you have that much further to invest before you can hit these minimum targets. And it's going to make it that much harder, in 3 or 4 years for new entrants to come in, because people will be consuming, 50,000 tons per plant. They aren't going to want a 1,000 ton supplier to enter that supply chain. And so I think executing on reaching scale so we can build into that, growing demand is certainly the most important thing. And for me, I think that's where our biggest risk lies, is that execution, and I think the biggest excitement is the same, right? I mean, the opportunity is immense in front of us. And if we can do better than our forecast, the demand is, as I said, insatiable. And that's just looking at our anode division. And now with the progress we've been making with our cathode technology and some of the earlier stage programs, we're really looking to bring those up more quickly than I think we maybe thought possible a couple of years back.
Great. Thanks, Chris. We appreciate your time. We know it's the evening where you're based. A fascinating story and an incredible success story this year. I know there's a long way to go, but thanks again for your time.
Yeah, pleasure as always, Tim, and thank you everyone for coming.
By the way, we've had a question. this recording will be available on Share Cafe, a recording of this event on Share Cafe on our YouTube channel, probably over the weekend. Thanks for your time, everyone. See you again.